Welcome back, students, for one more new video based on GCD of two numbers. Find the GCD of 32 and 54. Find the GCD of 32 and 54 and express in the form of 32x plus 54y. First, let us discuss. Here we are using the Euclid's method to find out the GCD of two numbers. If you know the definition, it is well and good. Otherwise, just I will tell you the definition. Just look at. I have a number 6 and 12. So how to find out the GCD of 6 and 12? The basic idea is, first you have to find out the divisors of 6. Divisors of 6 are 1, 2, 3 and 6. So divisors of 6, divisors of 12 are 1, 2, 3, 4, 6 and 12. Okay, now let us find out the common divisors here. Common divisors are 1, 2, 3 and 6. Out of these 4, which one is the greatest one? Greatest one is the 6. Therefore, GCD of 6 and 12 is 6. So how to get this? So how to get by using division method is very simple. We are using the successive division, that is called Euclid's algorithm. So you have to go for successive division. Once you get the remainder is 0, the non-zero remainder become the GCD. Since there are only two terms, here you can divide 12 by 6, 6 2s are 12, the remainder is 0, the last non-zero remainder is 6, therefore GCD of 6 and 12 is again 6. This is the way of writing the GCD. GCD of A and B is D. D is 6. So here I have 32 and 54. I am going to divide 54 divided by a small number 32. As I told you already, we are using the Euclid's algorithm. Euclid's algorithm is the method to find out GCD of two numbers by using the successive division. 32 ones are 32. So 4 minus 2 is 2. This is 22. Every time when you divide, you need to express by using division algorithm. That is, 54 can be written as 32. 32 into 1 plus the remainder is 22. But we want a remainder, student. 22 write as it is, you transform to left side. 54 minus 32 into 1. Okay. Similarly, we can divide 32 divided by 22. 22 ones are 22. The remainder is 0. Here this is 3 minus 2 is 1. So you can write directly, or 32 can be written as 22 into 1 plus 10, and 10 can be written as 32 minus 22 into 1. Finally, 22 is divided by 10. 10 2s are 20, the remainder is 2. Similarly, 10 can be written, here that is 22 can be written as 10 2s are plus remainder is 2. Okay. So therefore, the remainder can be expressed as 2 is equal to 22 minus 10 into 2. Finally 10 by 2. 2 5s are 10, the remainder is 0. Therefore last non-zero remainder, go for last non-zero remainder is 2. 2 is the GCD. Therefore you can write GCD of 32 and 54 is 2. That is 32 comma 54 is 2. So you just remember these equations 1, 2, 3 because these are very useful to express GCD of 32 and 54 in the form of 32x plus 54y. So let us take the last equation. The last equation is two is equal to 22 minus 10 into 2. 2 is equal to 22. What is 22 value? Substitute it. That is 54 minus 32 into 1. Okay. Minus 10. What is the value of 10? 10 is equation number 2. Just substitute the value of 10. Okay. 10 value is 32 minus 22 into 1. Okay, multiplied by 2, which is 54 minus 32 into 1. This is 32 into 2 minus plus 22. 1 into 2 is 2. Okay. Fine. Now, okay, this can be written as 54 minus 32 into 1, 32 into 2 becomes 32 into 3 plus, once again use the value of 22. What is 22? Can go back. 22 value is 54 minus 32 into 1 multiplied by 2. 54 minus 32 into 3, 54 into 2 minus 32 into 1 into 2 is 2. Okay, fine. So 54 means 54 into 1, at least it is multiplied by 1. So 54 into 1 into 54 into 2 becomes 54 into 3 minus 32 into 3, 32 into 2 is 32 into 5. Or write in the reverse order, this is 32 into minus 5 plus 54 into 3. This is same as 32x plus 54y. So we have expressed GCD2 as 32x, where x is minus 5 and y is 3. 32x plus 54y. So that's it. Thank you so much for watching. We'll meet in the next video, students.